Meanwhile, less people are joining. Prashad, can you please explain a little bit about yourself? From where you are? Are you in the India currently or no? Okay, are you working on F5? How much total experience? Just a brief introduction.
Sure. So my name is Prasad, and I'm working since last 8 years in networking. So currently, my job profile is a network expert with the Telstra Limited. For I'm serving for like multiple enterprise client over here, and I've required this course because this is a part of my job right now, and I have to do on daily practice. Means like daily tickets for certificate renewals and troubleshootings are there. So that's why. Thank you.
Sure, thank you. So before starting, maybe Gopi and Stephen and Prashad again. Okay, you can just introduce about yourself. You just need to tell how much total experience you are, from which country you are, and F5, are you aware about or no? If yes, then up to what limit? If no, then even fine. So let's start with Gopi. Gopi, please introduce yourself.
He's outside right now.
Okay, let's go with Stephen. Stephen,
Yeah, so my name is Steven. Hi everyone. I live in the United States, Maryland. And I'm presently a desktop analyst. And I came across F5 last 2 years, but I was stuck by doing something else. So right now I really want to know much about it because I'm interested in it.
great, 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 great. So Prashad already introduced. He is from India based and having 7 years of experience. Good. Okay. So Gopi, at least you can put over the chat if you are not able to speak. Okay, maybe we will see this afterwards. Now, myself is Radhe Verma. You can see my profile over here on your screen. I hope you are able to see my screen, right, everybody? Is my screen visible to you?
Yes, sir.
Oh, okay. So today we would be going to talk about a brief introduction about F5. So let's start. Yes, Gopi, you are unmuting yourself. Go ahead.
Gopi have 4 years of experience as network engineer and 2 years
Hmm.
of FI experience.
Okay. Let's talk about F5 LTM. Okay. F5 LTM, when we are going to talk. So one thing you people should be aware that there is a company whose name is F5 Networks. Okay. It has a lot of platforms, or you can say footprint in different areas, including one product family is named as Big IP. Okay, so this is one of the, you can say, main department, and out of which if you see closer, there would be LTM, GTM, ASM, APM, ARM, AFM, and a lot of list goes on. Okay, today we are just talking about the functionality of LTM, and in our class, which would be leading to 10 to 15 of the hours, will be focusing on F5 LTM only. Okay, so LTM is really very interesting stuff, and you can say it is the base for rest of the technologies. In market, if you will see, there are lot of openings for the people who are aware about F5 networks. Okay, if you are aware about LTM, GTM, ASM, and APM, there is really a very high package waiting for you depending upon the opportunity and the city where you are living. Okay, so it is really taking pace in the market, and it is a market leader, you can say, and not from today, or it's not trending nowadays, but from the past few years it is literally having the full grab in the production network. Now, when I am going to talk about FI LTM, LTM means local traffic manager. Okay. So what is local traffic manager? Local traffic manager means you are locally what? Data center. With respect to data center, we are saying it is local. So locally, you are managing the traffic. That is why probably they put the name LTM, because in this case, you are locally managing. But later on, if you guys will be interested for GTM or another technologies, you will be able to understand GTM is the previous name. Okay, it's no more there, but in day-to-day language, we used to say GTM. It is named as Global Traffic Manager. Global Traffic Manager. So GTM, new name is F5 Intelligent DNS. Okay. Now it resolve the DNS query. And when it resolve the DNS query, let us say there is a GTM box. It resolve the DNS query between two data centers. So let us say you have two data centers. Okay. Some applications are hosted over here. Some same application are hosted over here. Now let us say this data center is from US, this is from India or Asia. Okay. Now if the users are coming from the US, GTM is well aware that okay, it is from the US, so it will send those users to the US data center only, so that your application performance could be enhanced, latency can be reduced, blah blah. Okay. If user is coming nearby to the Europe or maybe nearby to the US, again, it will gonna go to the US only. But if they are closer to the Asia region, they will go to the India data center. Yes, Stephen, I can see you are unmuting yourself. Go ahead. Any question? No? Okay. Then, as I was mentioning, there is a module named as ASM. It is again the new name is Advanced WAF. Again, full-fledged course like GTM has full-fledged course, LTM has full-fledged course, ASM has different full-fledged course. Advanced WAF is a device, you can say, which keep on checking if there is some traffic is coming for our data center, for our application. Let us say this is application. Here we have the users, and here we are using F5 WAF. So F5 WAF will see that, okay, the request which is coming, it should send to the user or no. If this request is legitimate, there is no attack, there is no issues, this request will be forwarded. But whereas if this request has some of the vulnerabilities exposure or anything of the, like the suspicious activity, then it will be get blocked on the WAF end, so that it should not go till our application server. So WAF is your layer 7 inspection. Okay. So I can say for it is an advanced web application firewall. Okay. And if you talk about ASM, it is application security manager. So earlier they gave this name application security manager, but the new name is advanced web. Web stand for web application firewall. So far, is there any doubt to anybody?
One question, please. So you said the ASM used to be the previous name for WAF. Is that what you're saying?
New name is advanced web. Previous name was
Advanced.
ASM.
ASM. So okay, so ASM is now advanced web
Advanced web.
application firewall. Okay,
Yes.
thank you.
Sure. So I was explaining, maybe Damola, you just joined, yeah. So I was explaining about GTM, I was explaining about LTM, how these names are coming into the picture. I was talking about those terminology.
Oh
But
yeah.
now,
Yeah, I was there. My name just changed from Steven to Damola. I don't know what happened.
Yes,
Yeah.
I'm
All right.
changing his name.
So I don't know. We
It's
changed
allowed.
it. I don't know.
It's allowed.
So
It's allowed.
it's still the same
Now,
person.
that's good. Now, let us talk about the overview. Okay, today I am just talking about the overview. So, if you see F5 LTM packet flow, okay, I would be just giving you the overview of F5 LTM packet flow. Just give me a minute, guys. There is a lot of disturbance from outside. Let me close the windows. Okay. So here, what I was describing about F5 LTM packet flow. So what I am talking about today, that when some packet or request comes from the client, how your request will be forwarded to the LTM, and what maybe majorly, not I can describe everything in this class because there are a lot of things, lot of configurations which are required, which we would be going to talk later on in the our upcoming sessions. But today I am just talking about how your F5 LTM, which is very popular solution for your application delivery controller. So it is named as ADC, application delivery controller. Very popular solution for your application to be managed, to be optimized, the traffic flow between the client and the servers. So I am just trying to explain you step by step so that you people can make your mind that how it is working. Let us say there is a client. Okay. Client need to talk with some of the application. This is your application server. Okay. Client can talk with application server sending the request. Maybe it is an HTTP request. Okay. And the HTTP response is sent back. Right. So they are talking with each other. But what if this is local, maybe local to the site? Okay. What if the demand for this application gets on increasing day by day? Let us take an example of Facebook. So when Facebook was started, it was for maybe within a college campus. Yeah. Few people were just engaging them. But later on, demand is increasing day by day. We cannot have a single server sufficient for handling such a huge data. We required multiple servers. So let us say now client need to go to have the applications, but this time there are three servers. So when client is coming, there should be some of the device, let us say router, switch, layer 3 switch or something, which is sending this request. But the problem could be when request is going over here and it is down, client will see that it is down. Okay. Client can see that it is down, which is not good. Why? Because two servers are up. Ideally, the request should go to the rest of the servers rather than this. But this poor device is not capable enough to see which server is up or which server is down. But it can do the load balancing. The load balancing, what it is doing is it is sending one packet over here, second packet over here, third packet over here. This type of load balancing is named as RR, round robin. So very poor, I would say, it can be used, but not a good way when you have such a huge application users. Now, let us introduce LTM in between. So LTM will be before. I am talking about the logical flow, not the complete physical topology. Complete physical topology can vary. So let us say LTM is coming in between, and now you have some of the application servers. Okay. So very first thing will what it is client request. So your traffic flow will start from the client request. When client will send a request, if it is an HTTP request, it will be doing TCP handshake. Okay. And everything. It would be gonna done with LTM first, and from LTM another request will go to your backend servers because it is acting as a full proxy. Okay, I would be coming to these points in a moment. First, let us understand the first point is client request. When client is sending a particular resource access to your web server, okay, just to make a request. Now, going forth, client request will go to your LTM, and maybe we can introduce over here a term named as virtual server. See, what happened is, let us say this is again, I would be gonna create the same diagram multiple times, okay? Because you people should be aware what I am doing. So here is LTM. From LTM, again, the data will go to the backend servers. Just for the simplicity sake, I am creating two, but there can be multiple this backend servers, okay? So when your client request will come on the LTM, when I am saying it will come to the LTM, who will handle? LTM is a bit like you can say, complete box. So it's bit like you are living in a building, okay, and I am sending some packet, or sorry, some letter. So that letter should be handed over to you, not to the building. Yeah. So from building, there are some of the flats. Now, on which flat you are living, probably there the letter should go. Similarly, this client packet will go to the virtual server. So virtual server is, you can say, a virtual configuration object, what we are creating on F5 LTM device, and it received the client request for that specific application. So here on the LTM, there can be a number of applications. Let us say it is hosting 100 applications. xyz.com, abc.com, netminion.net, okay, netminion.com, then n number of website it is hosting. Where this packet should go, which virtual server, so that you will be gonna create later on. How to create, I will gonna talk about in our upcoming sessions. So here in LTM, the request will go where? To the virtual server. And virtual server is what? It is a logical representation of the destination service, and virtual server is associated with the pool. Pool of what? Pool of servers. So let us say there are some other application here. So here we would be having another pool, okay, for this particular application. And for the same, we must have another virtual server. Let us say virtual server 2, virtual server 1. Virtual server 1 is going to the pool 1. Virtual server 2 is going to the pool 2. Making sense, guys? So far, any doubt? So your request will go to the virtual server. Okay, this is the second, like I am just going with the sequence by sequence. So it is the second packet, sequence while we are discussing about the packet flow. Okay, I hope no doubt. Let's proceed further. Third. Now I am talking about with you that I am saying here the overview. Okay, not the complete details, because in one class we cannot complete this. Now LB decision will made. So in the packet flow, I am talking about the LB decision sequence, which is coming to the third. So client request is reached to the virtual server. You people understand that? From virtual server, this request should go to one of the backend server, which are exactly hosting this website. Okay, let us say xyz.com. So it reached till here virtual server. From virtual server, there is a pool associated. From this pool, either the packet should go over here or packet should go over here. It is decided by LB. So LB balancing decision, you can say it is a decision about which pool member should handle the request. And this decision is based on various of algorithms. because LTM is not bit like your layer 3 router that it will be just sending the round robin, one request there, one request there. No, no. It will be gonna check the various of the algorithms. And those algorithms can be static in the nature, or it can be dynamically derived or static in the nature. So when I'm saying static, means you are defined like server 1 should be having the ratio 1, server 2 should be having the ratio 3. So by this way, if first packet is coming, it will come here, second packet will come here, third here, fourth here, then fifth packet here, sixth here, seventh here, eighth here. It is bit like statically you are defining that one of the server is the new server or the capable enough to handle the more requests, right? So more requests will go there. But in case of dynamic, if there are two of the servers, so LTM will check, okay, buddy, either you are having more CPU consumption or more traffic which you are handling currently, those requests are in wait in the pipeline. So who is less overheaded? Let us say server 2 is less overheaded. Okay, request will go over here. In some time, server 1 is lower overheaded. The request will go over here. Trying to balance the request. Okay, again, your both of the servers should be having in balance. So this kind of load balancing mechanism, again, as I am telling, we would be going to talk about it later on. But the third point in the packet flow, this sequence is clear to everybody, or if there is any doubt, I can explain again. Feel free to ask. Any doubt, guys?
Yep. So I want to know, like, the LTM has given the same the algorithm they have, like the round robin, uh, or any list weight connections are there. Okay, but the same thing we will do with the DNS server itself. Then why we are using both of things, like DNS as well as LB?
Right. So you are talking about two different, I would say modules here. One is LTM, one is GTM, right? So although it is not a current topic, but let me explain. I want mine to explain that. GTM is using something named as GSLP, Global Server Load Balancing. And if you talk about load balancing there, here the load balancing one time. Their load balancing happened two times. One on the wide IP level, second on the virtual server level. Probably this can be, more complex to you guys. Okay, I can explain this in the DNS demo. But are you understanding what I am trying to tell here, Prasad?
Yeah, got it. It's look like the DNS will be work onto the WAN perspective itself. Okay,
GSLB.
and the,
So GSLB
yep,
means globally. Globally
globally,
means
right?
over the data center.
Got it.
Okay. Whereas your LB is local to the data center, as I started our class with these words.
Got it.
Okay.
Got it. Now I got it. Yep, got it. Yeah.
So that is the reason, like, your LTM is not capable enough to handle your all the requests which GTM can do. But again, if you're interested in GTM, probably I would be gonna take a GTM demo also in some time. Okay, in some weeks. So you can just join there and you can understand. Okay, I will be gonna talk more about GTM.
Okay.
Sure. So point number 3, LB decision till here. I hope so. There is no issues. I am proceeding further. Now, point number 4 is very important for you guys. Okay, and you will be able to understand it more during the our practical sessions, which is fourth. So during the lab, probably you will understand it more. SNET. SNET stands for, some people are saying it is a secure net or source net. Okay, so I am just mentioning source net just to avoid the confusion here, but it can be a secure net also, right? But these two terms are interchangeable. So what happened is, again, let me create that diagram. There is a client is coming to the LTM, Okay. And when I'm saying LTM, it is coming to the virtual server. From virtual server, it can go to backend server, right? Now, what happened, guys, when you are migrating LTM, like let us say in your environment, currently there is no LTM. You need to put it. So you should be having couple of the interface over there. These interface can be towards the client side is named as, generally we can take any name, but we are just saying external VLAN. We are creating an one VLAN, okay, for the segregation of the traffic, like external VLAN. The one which is going towards your server, we used to give the name internal VLAN. Again, it's not necessary that you need to give these name only. You can have VLAN 10, VLAN 20, bit like that also. But it's good if you do the naming convention as such that it could be relatable. Now, if you have two LTM box, LTM1 and LTM2, one VLAN will be traversing between them for your high availability named as HA VLAN. And last but not the least, for taking the management of your device, because there should be out of band management, you should not be using the external VLAN IP or the internal IP or the HA VLAN IP to log in into the device. So you should have management VLAN. So if you guys can relate, how many VLANs I created here? 4. Okay. It is standard migration with, sorry, 4. 4 VLAN I created, which is a standard migration and named as 2-arm architecture. There is one more architecture when external or internal VLAN can be same. Okay. But again, we would be going to talk about later on. And this is named as 1-arm or single arm architecture. But let's not, deviate ourselves from our topic. Our topic is SNET. And I am going to talk about this because I required this VLAN information. So I just created these 4 VLANs. So far, any doubt? Now let me proceed, or let me use Paint. Give me a minute. Okay. So using Paint, probably I can create something very quick for you guys. This is LTM, and this is client, and I'm just creating one backend server. It can be multiple. You people are aware now. So I'm just creating that. From client, my request will go to the virtual server. From virtual server, it should go to one of the backend server. Let us say server 1 is selected. So I'm just mentioning here. Client. Client. And this is my F5 LTM. And this is my backend. Now, when I was mentioning you that we would be going to create a virtual server, it means virtual server will be having some IP. I am just considering it has the IP 111 with port 80 or 443, any port it can be. Client should be again having some IP. Let us say I am saying 192.168.1.1. Okay. And when it will generate a request, it will use any of the random port, which would be higher end port. You people should be aware about that, right? Because you are from the networking background only. All of you have a good experience. Let us say server IP, the server which is selected to us is 172.16.1.10. Okay. So when I am saying external VLAN is 111.80 over here. And when I am talking about internal VLAN, on my device, there should be some IP, let us say 172.16.1.1, which is going towards the internal. Okay. Okay. Now let me create one more box here so that you people can able to understand. Okay. Now what happened when request is initiated by your client? So this request will be having 192.168.1.1 as your source port. Okay. So your source port would be what? With IP is what? 1.168.1.1, and your source port can be any. So I am just saying, let us say source port is 444, any random port. Post that, this request will go where? So when it is accessing any website, let us say xyz.com, DNS will come into the picture. DNS will resolve that IP to your virtual server. So what is this? This is your client. What is this? This is your virtual server where client will come on 1.1.1.1 on the port 80. So your request from the client when going to the LTM, it will be having on virtual server 111180. Let us say there is no secure net. Okay. Your LTM will initiate a traffic flow to backend server. So this 192.168.1.1 444.4. This request will be, the source will be not changed. But when it is going to the backend server, it will change the IP that, okay, you need to go to the 1.1. Let us say it is also running on port 80. So this is how your request will go without SNAT. It sometimes people used to say it as a destination NAT because your destination IP is getting changed. So far, what I was explaining, please try to understand about the same. Okay. Your request from the client. Okay. From the client, your request will go to the virtual server, right? So client IP is mentioned here. Port can be any higher end port. Then since it is going to the virtual server should have some IP and the port defined, which we are defining over here. Okay. So client to virtual server, this is one packet flow. First packet flow. Then from F5, this request will go to the server. This is your second packet flow. So when F5 will send this request to the server in your second packet flow, F5 is not changing anything, right? So source IP is as is, but your destination IP is changing to the backend server. And since server should be running on any of the service, it is named as pool member, by the way, pool member. Okay. So your pool member is running with port 80. So that request is forwarded to your pool member. This first request is only destination NAT. Okay. It's not changing the source. There are some problems which can occur due to this design. And that is the reason we introduce SNAT. What are those problems that we would be going to discuss about in our class? But currently I am just talking about the second flow which is using SNAT. So when we are using SNAT, what happened? Let us see. Okay. Again, traffic is initiated by your client with some port. I am taking the same port. Okay, it can be different port also because upper end port can be anything. Traffic will be going to your virtual server. on the IP and the port defined over there. Then when F5 need to send it back to the server, since you are changing this time the source also, this source will be changed to 172.16.1.1. Port will be intact, the same port, okay, or and backend will be 172.16.1.1 with port 80. So in case of SNAT, there are two changes happened over here. The first change is that you are not only changing the destination. So earlier, this was your source, this was your source, this was your destination for first packet. Second packet, this was the source, this was the destination. Your source was same, not changing, but your destination was changed. That is named as DNAT. This time, your source is also changed, your destination is also changed. Are you guys able to relate it? Yes or no, guys?
It looks like the internet working is there, right? Destination net.
So that I would be going to explain more, okay, about DNAT, SNAT in our classes. But currently I am just trying to tell you when your packet will come on F5, what all things happen. So one of the thing which happen is SNAT. Okay. Fine. So in SNAT, what F5 will do? F5 will translate the IP and it will make its own IP. It will say that, okay, I am the requester now in the second packet flow. So in second packet flow, F5 will initiate the traffic towards backend server. In first packet flow, your client will send it to the virtual server. Now, when reverse traffic will come, it will come to the LTM now, and LTM will rewrite back to the client. Client won't be able to relate that either this request is fulfilled by LTM or there is something in between. So since LTM is going through these all changes for the client, it is doing a proxy. So it is full proxy architecture. Okay. What is proxy, by the way? Anybody? What is proxy? Please share your views so that we can, this client, this thing can
Proxy,
be. Yeah.
Proxy looks like we have the one internal IP addresses, and we are want to access internet. So we will do some configuration on the browser inside, wherever like something we can hide behind the firewall or not a firewall, so proxy server.
Right. So what happened is, let us say in your environment, although if you will go to the blog NetMinion, okay, here you can see there are a lot of, you can see there are a lot of blogs are there. One of the blog is from the proxy. Let me just search for it. Give me a minute. So you can see one is your DHCP proxy and DHCP bridging. Okay. One is your forward proxy and reverse proxy. So you please go ahead and read about this blog. Okay. I am just sharing the link over here on the chat as well. Where is my Zoom chat? Here you go. Okay. You just read about it more, but I am trying to give you an overview. What happened, guys, when as you were mentioning, right, Prashad, clients wanted to go to the internet. Client's IP is private. Private IP cannot go to the internet. So you have a box in between, which is acting as a proxy, and this proxy will go to the internet, okay, and can go to any of the maybe Facebook or maybe any of the banking website or maybe any of the knowledgeable website So anywhere you are going, maybe you are reading about some blogs on the NetMinion blog. So this request, when coming from this client A IP will be hidden. Why? Because from that private range, it will be introduced with the public IP, because your private IP cannot go to the internet, right? In the reverse, again, it will be converted back, okay, from public to the private. Secondly, this proxy has some of the database. Again, this is an off topic, but I am just talking about literally overview. So proxy will check from its database that, okay, the client A, which website it is going to access, maybe some website which are not good, maybe some adult website or some other thing, it will be get, block at once. Why? Because in proxy database, these are not allowable websites. So that is how one proxy is sitting over there. It is named as reverse proxy. Okay, when clients are going to access the internet. But very, if I will be going to talk about just an opposite, if clients are coming to your data center for accessing an application, you are hosting an application, let us say. Okay, let us say you are coming to the NetMinion website. It is in my data center. I cannot reveal my NetMinion server IP address on the internet. There can be so much attacks, there can be lot of things, or maybe there are couple of the servers over there. How many servers I will be gonna put there directly? Okay, so there will be one proxy device over here. So my request will come over here, and instead this request will be load balanced by this proxy device. So when it is in front side to your servers, the same proxy, the same feature, everything is the same, is named as forward proxy. And your LTM can act as a forward proxy, can act as a reverse proxy, and it is a full proxy device. Okay? Make sense, guys? Yes or no? Any doubt? You can ask. No doubt? Fine. So that was the overview of your packet, right? There are multiple things which come into the picture, like persistence. So persistence is session stickiness, bit like you can say. Then there can be health monitoring, which is again a very important topic. Why? Because let us say this is LTM. LTM has a pool. There are couple of pool members. Let us say this time 3 pool members. Okay. If this pool member is down, my F5, when request is coming to my virtual server has this pool. Okay, this pool is associated with the virtual server. Virtual server won't be gonna send any request to the down server, so that your application uptime can be maintained. So monitoring will come into the picture. Post then, there is some scripting can come into the picture named as iRule, which can change the default behavior of your F5 device. Probably we will be going to talk about later on. So F5 will come into the picture. Sorry, iRule can come into the picture, and there are a lot of profiles we will be going to discuss later on. So profiles can be come into the picture. Eventually, the overview of packet flow I have described, but it can be altered with couple of more configuration objects. Like iRule, there is something named as LTP, local traffic policies. Okay, so that can also come into the picture. So far, any doubt to anybody, like how your F5 LTM will entertain the traffic coming from the client? Is there any doubt? Any doubt? No? Good.
No.
Fine. So let us say you can just, see the timing based upon your countries, because there are from multiple countries people. Let us say our class is starting from 10. Okay. You please be available till 10:05. So 5 minutes is the buffer time. Okay, you guys just have the 5 minutes, but within 5 minutes, just come because we need to value the time for others also. We cannot wait much. And from 10 to 12, let us say our session is. So at 10:05, 5 minutes, we will start. At 11, approximately 1 hour, 55 minutes, 50 minutes, bit like that. And after 1 hour, we will be gonna take a 10 minute of break. Okay. So you, if you have some of the work, please be on hold till 1 hour. After that, 11, 10 to 12, okay, or maybe plus minus 10 minutes, whatever, we will be gonna take the class after the break. So that is how our schedule would be. In our class, we will be gonna focus for working professionals, like in your day-to-day environment, what kind of job you need to perform on the LTM. We will be gonna talk about that. We will be gonna talk about with respect to the certifications. If you want certification to be get cracked, how you can crack that. Okay. And then we will be gonna talk about the interview perspective also. Like if you are going for the interview, what kind of questions can be there? Okay. So this include the T-shoot also, because every topic has the T-shoot included in it, right? So some people in the market say that, okay, we are taking such a troubleshooting classes, maybe for 1 hour, 2 hour, 3 hour, 10 hours. All that is a, maybe I would say, marketing strategy. Why? Because troubleshooting is an approach. It's not bit like that you can teach to somebody, something uh, out of the way. If there is some topic of SNET, there is some topic of monitoring, there is some topic of routing, probably that topic should be cleared first. If all the logics are cleared about that topic, person can do the troubleshooting by its own, because you need to build that approach. Okay, it's not about some topic, it's an approach. So that is how we will be gonna talk about. And then if I will show you the lab, how many of you have enrolled for the lab? If not, that's fine. Okay, you can just take the lab if you are requiring that, which I must say you should take, because without lab, there is nothing. And in your production environment, you cannot have every, simulation you cannot do on the production environment, because production has its own, some changes. If you are going through, you need to go through the change management, or some your production traffic can also hamper. So I won't never suggest you that you do the work on your production environment. So here you can see we can create an HA lab. Okay, we will do some iRule lab, monitoring lab, all of those labs we would be gonna use this kind of topology. And within this topology, we would be able to complete our all of the stuff. Okay, so this lab you people will get. Any doubt so far to anybody?
Sir, I just came. I have registered for lab.
You will get the lab then, don't worry.
Yeah.
Okay, those who have registered for the lab, you will get. So I would suggest that you please go through these videos recording also, like we are doing it in the weekends, in the weekdays. Okay, in the weekdays, go through this recording. This recording will be you. Everybody of you will register. You will be having this recording over the web portal, over the application you can access. Either you have Android, you have Apple, whatever. So you can just go over there and you can check how that. Probably you can check with Zoya. Okay, she will be gonna talk about the same. So just focus, I would say, for 1 month at least on this technology, so that you can have one more for in your bin. Okay. For today, we are just wrapping it up. If you have any questions, guys, please come up. Damola, any question? Anything?
So concerning the lab you talked about, um is there anything we need to do from our hand before we install the lab?
Right. When we will come to the lab, I will share a workbook with you people. Okay. Even I will explain you how these lab components need to be created. Okay. Then you can just use those things, and using those resources, you can able to configure it by your own.
Okay, makes sense. Thanks.
Yeah. So lab will come into the picture probably next weekend, not now. Gopi, any question to
Okay.
you?
No, sir. I'll go through this video again. Then we'll sort it out next week.
Yeah. Prasad, you have any questions?
No, not now.
Okay then, gents. Let's wrap it up for today. Have a very great time. Good day, good night, as per your country. Okay. And we will meet next week. Okay.
Okay, sir.
Thank you.
Sure.
Bye.
Thank you
Bye.
guys. Bye.